Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to look a little deeper into group descriptors. And in particular, we're going to show you how you can use some Python in order to read these out from the earlier part of your disk. By way of warning, we've been in this fundamental topic of looking at the big picture of Ext file systems and what they look like for a while now, but I promise we're nearing the end, and this is very fundamental stuff, and understanding how the disk is laid out will really help you when it comes to doing your investigations. All right, so let's get to it. So here I have my Python code, and it begins with the same code that we talked about in an earlier video. And to that code, for the super block, I've added a new class. And the new class, not surprisingly, is called group descriptor. So here's my class. And this class will read in the information from the raw file image. So you pass in the start of the data, and you also pass in a flag as to whether or not this is using wide group descriptors or 64-bit group descriptors. So if you're using the 64-bit option, if it's an ext4 file system, because earlier ones didn't support this, then you will have a longer group descriptor. How much longer? It'll be twice the size. So instead of being 32 bytes, it will go to 64 bytes. So this one is a lot simpler, at least shorter than the super block. And I use the same convenience functions that we talked about before. And I get the block bitmap location, the inode bitmap location, inode table location, number of free blocks, free inodes, how many directories are in this group, what are the flags, and as before, I defined a method that will go from the flags to a list of those flags. There's an exclude bitmap, and then there's checksums. So there's a block bitmap checksum, an inode bitmap checksum, and the unused inode count. And finally, for most cases, again, if you're not using the 64-bit option for ext4, we end with a checksum, and that's it. So here, if you said, no, I'm going to use the wide option, you will see the high double word for most of these options. Some of them are 16 bits, but most of them are 32. Right, so everything doubles in size, including this block. That is pretty simple. Here's the print flag list method. There are only 3 flags currently supported: inode uninitialized, block uninitialized, or inode zeroed. Inode zeroed is probably the most common flag that you will see. And once again, I have a pretty print. And I make use of the fact that all of these Python classes have internally a dictionary, and then I iterate over that dictionary and print everything out for you. Pretty simple. The other thing that I've done here is I created another class, and this class is called ext metadata. Now, why do we have this class? We'll talk more about this in a future video, but you have just the raw data in these group descriptor tables, and you have your super block. But to get the real picture of what's going on in each block group, you really need to combine those two items. So I've started this ext metadata class. We will expand on it in some future videos. But essentially what I'm doing here is I read in the information, I check to see that it exists, I read in the super block, put it into an object, which I then store. And before I can read in my descriptors, I need to know a couple of things, such as what's the size of the descriptor? Are we using wide descriptors or not? So once I've determined that, and I determine that again by looking at the super block, right, I look at the super block, I get the number of block groups. I also look there and I get the descriptor size. Now, if I'm using regular descriptors, the descriptor size will just be 0 if they're 32 bytes. So here I use my recommended with open construct, and I read in all of them in one big fell swoop. Then I create an empty list, and I go over my block group descriptors, and I load each of them into a proper object, and I add those objects to my list. And as usual, I define a prettyprint function where I call the superblock prettyprint and then the block group prettyprint. Now my main method has become super simple. All I do is check to see if you gave me enough parameters. Then I will check to see that the file exists. Once I've determined that the file exists, I call ext metadata. I pass it the file name and the offset. That creates my ext metadata class. And then I call ext metadata prettyprint. And that's it. I'm done. So it's a very basic program. So now let's actually run this script and see what we get. So if I run my script, it's extfs.py on media, Phil, Toshiba, disk images, our favorite disk image so far, 2015, 39, IMG, and recall the offset was 2048 sectors. I run it, and here's the output. So you'll notice that this looks very similar to what we get from fsstat. And again, why did we bother to do this? We bothered to do it because fsstat and the sleuth kit are not necessarily up to date, and also because we might want to develop our own Python classes so that we can use them for other things. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.